Welcome to our final lesson on the Geneva mechanism. In this lesson, we're going to be putting our model to the test. Let's begin with a new assembly document. And let's click on Create Layout. First, let's drag in the base block. Release the mouse button to place it, and after I release, I'm still able to drag the block. I'm dragging by the insertion point. For example, I can snap it to the origin point. I can use the Parameters section in the Insert Block Property Manager to adjust the scale, as well as the angle of the rotation. Here's what 45-degree rotation looks like. To change the rotation angle makes sense when you're snapping the insertion point to some existing geometry. In my case, I'll just drop the block in the graphic area. And let's cancel out of the Insert Block Property Manager. I'll grab the block by this point, snap, and select this line and add a horizontal relation. Accept. Let's insert the crank next and then the wheel. Browse. First the crank. Open. Let's drop it in the graphic area. Grab by the center of the circle and snap it to this point. OK. Lastly, let's bring in the wheel. We'll drop it about here. Cancel out of the Insert Block window. Now let's grab it by this point and snap it to this point. And let's take a front view. At this point, we're able to do some limited testing of our mechanism. I'm going to add a coincident relation between this point and this line. Let's put both entities in the approximate position. Control-select the line and this point and add a coincident relation. OK? Now it looks like we've got a problem. The center of the pin, which is right here, should be located along the radius of this arc. Let's right-click on the crank, select Edit Block. We quickly see what's wrong. I'm simply going to add a fix relation. Notice that most geometry is turned black except this little circle and the construction line. Looks like I missed a second construction line and angular dimension. So let's fix these as well. Insert a center line. Right-click and select. Now Control-select both of these new lines and add an equal relation. Lastly, let's delete the fix constraint. And exit the block. Rebuild. Again, let's do some limited testing of our mechanism. And let's go back to the layout. Let's delete this relation. Next, let's convert the blocks to parts. Right-click on the base, select Make Part from Block. Block-to-Part constraint on block, and accept. Same thing for the crank. Make part from block, on block constraint, and accept. Last one, the wheel. On block and accept. Let's hide the crank and the wheel. Right-click, hide. And let's do the wheel now. Right-click and hide. We'll also hide the layout. Right-click and hide layout. I'm going to edit the base now. Let's select the sketch. Extruded boss base. This extrusion is going to go 5 millimeters in the negative Z direction. OK. Let's select the sketch again. Extruded boss base. Now we'll use selected contours. Let's select here and here. From, offset, 5 millimeter offset. Tab to register. Let's change the offset direction as well. And the extrusion depth, 25 millimeters. Let's right-click and change the color of our part. Let's make it, let's say, dark blue. And let's exit part editing mode. Right-click and show the crank. Now let's right-click on the crank and select Edit Part. Let's select the sketch again, Extrude, select this contour, extrusion of 10 millimeters, tab to register. Since we want the crank to sit on top of the base body, the extrusion will have to be in the positive Z direction. Let's accept. Select the sketch again, Extrude. Selected contours. I'll select this contour and this one. 20 millimeter extrusion. Accept. Let's right-click and change the color of this part. At the part level, let's say light blue. Accept and exit. Lastly, let's bring in the wheel. Right-click, Show. Right-click and Edit. Once again, I'll pre-select the sketch. Extrude. Select the region. Extrusion depth of 10 millimeters. And we'll offset it by 10 millimeters as well. Be sure the offset's going in the right direction and accept. Let's right-click and change the color. Maybe to red. And let's exit. Okay, here's our mechanism. Let's test it out. Instead of using the layout mates, we can use regular mates. Let's click Delete. Yes to confirm. This one as well, mates. Let's delete this mate, delete, and confirm. And let's go to the Assembly tab. Deselect everything. Activate the Mate tool. And I'll select this edge and this edge. Apply a coincident mate and accept. OK. Now let's select this edge and this edge, coincident mates, and accept, and cancel out of the tool. Now let's test how our mechanism works. I'm going to select Move Component. From the Options section, let's select Physical Dynamics. Notice we've got a collision between the pin and the wheel. Let's see what happens if I try to move the crank. SolidWorks gives us a warning. Model started in colliding position. Physical Dynamics has been disabled. Let's click OK. We can solve this problem in two different ways. I can position my pin in the middle of the slot, since I know I've got a 0.5 millimeter clearance on both sides. I've also got a 0.5 millimeter clearance right here. Let's test our model again. Move Component, Options, Physical Dynamics. And now our model works just fine. Another way would be to bring the mechanism into the initial position. Let's do that with mates. Activate the Mate tool. Select this face and this face. Apply the coincident mate and click Accept. Cancel out of the tool. Now after I apply this mate, the mechanism is now in the correct initial position. But in order for it to work, I'm going to have to suppress the mate concentric 1. Or I can delete it. Let's go back to Move Component, Physical Dynamics, and let's test again. And as you see, our design now works just fine. And this concludes our third and final lesson on this project, how to create an external Geneva mechanism without using calculations.